Let us begin saying that through this project, I'm going to try to explain the world based on the macroeconomic analysis. And I think that a good start should be what theory has to say about it. And it says that there are three important variables contributing to explain the macroeconomic performance of the countries. And those three variables are GDP, gross domestic product, inflation, and unemployment. Actually, there are a lot of economic and macroeconomic variables that could be selected, but after studying and thinking about this, I tried to come up with a simple method to measure the economic performance of a country, and I decided to go for a kind of index number, which is easy to calculate, handle, and read. After all, index numbers are one of the most used statistical tools in economics. So I decided to build an index number using these three macroeconomic variables based on the following reasoning. Okay, here is what many people want: a family, jobs, a good salary, and progress. And all these together is what should be called the pursuit of happiness. With this in mind, we are going to explain the economic performance considering that the real GDP should be growing and with low volatility. The rate of inflation must be low and stable, and the unemployment rate also low and stable. Consequently, when all this is happening, the expected result, among other things, should be a real GDP per capita high and growing. Now, we have just selected our three variables conforming the index to measure the economic performance, and the name is Macroeconomic Result Index, MRI. But this is not enough. I needed not only to measure the economic performance, but to demonstrate that the MRI has a strong relationship with another important variable, which is the real GDP per capita growth rate. Now, the formula for the MRI should look like this one. Okay, let's see the formula. The MRI is equal to the real GDP growth rate divided by inflation rate plus unemployment rate times 1,000. And here is a numerical example. A regular economy should have some numbers like this, and the result should be the MRI equal to 314. Okay, now after this, I have to demonstrate to prove two things. The first one is that the MRI index number represents a reasonable expression of the macroeconomic performance of any country in the world. And the second one is that the real per capita GDP growth rate is a function of the MRI. All right, let's do this. Okay, first step is to work with some data set. And after looking for information, I found this data set from the International Monetary Fund. 1,500 items from 1980 to 2021. And thinking in an efficient way of working with data, it was selected a subset of data for each country to analyze, meaning every country has its own data set with 42 years of information about the necessary variables for calculating the MRI and the regression analysis. The second step is to get organized for coding. And as a result, we've got three groups of countries. One for Latin American countries, another for European countries, and a special group for advanced economies, the USA and Canada. So let's coding now. For each country, it was calculated the MRI. And here is how it looks like the MRI for this group of advanced economies for 42 years. Now, I'd like to show you the performance of 40 countries around the world. But let's change to Tableau at this time. And here you can see the performance of each one of them. As a reference, we have the average with 216 and the 300, which I consider a good performance. And also we have here the lowest MRI with 59 for Greece. On the average, we have Paraguay, United Kingdom, Costa Rica, and on the 300, we have the United States, and the highest level of 459 for Switzerland. With this information about 40 countries during 42 years of analysis, I think that the MRI could be considered as a reasonable measure of the economic performance for a country around the world. Now let's go to the second challenge to demonstrate that the MRI has a strong relationship with the real GDP per capita growth rate. This is important because this can be used as an instrument to design economic policy. For that, it is needed to work with regression analysis, determination coefficient, mean square error, M as E, t-values, f-statistics, and some others. With this coding, we can plot the scatter between the macroeconomic result index, MRI, and the real GDP per capita growth rate. And at the same time, do the linear regression and get the coefficient of correlation, which is an indicator of the degree of correlation that exists between these variables. This process will be done for each one of the 40 countries in analysis, considering the 42 years of data. Here it is shown the linear regression for the advanced economies with a coefficient of correlation of 0.97, indicating a strong correlation between the variables considered. Then we have the US economy with a coefficient of correlation of 0.92, also indicating a strong correlation. And finally, Canada with a 0.95 indicating the same thing. That certainly is a particularly good start since it refers to important countries. Now we are going to calculate for 15 Latin American countries and for 23 European countries the MRI, the mean of the real GDP per capita growth rate, and the coefficient of determination R squared. And here we have the R squared distribution for Latin American countries, for European countries, and a summary for countries all over the world. As you can see, most of the countries around the world has R squared over 0.5, meaning that, and this is relevant, the behavior of the real GDP per capita growth rate is explained mostly by the MRI. But I would like you to see this in a different way. So let's go back to Tableau. Okay, here we are.
We tried to cover all countries in Latin America. And here we can visualize the MRI and the R square for each one of them. From Mexico, Costa Rica, Panama, Colombia, Ecuador. Here we have Chile, Paraguay, Argentina, and Uruguay. And here we have Canada with MRI 210 and R square of 90, and the United States with 299 and 85.5 R square. Also, most of the countries in Europe show a high R square between MRI and GDP per capita growth rate. And from Iceland, Sweden, Norway, and Czech Republic, Austria, Switzerland, Italy, Spain, Portugal. Okay, the size of the bubble is related to the MRI. Okay, so now let's see the world, but let's see the lowest value over here. Lowest value of the R square are these countries in Peru, Latin America, and in Europe, Bulgaria, Romania, and Poland, under 50% of R square. Then let's see at the middle values in here. Okay, there are several countries, and mean square is 76%. And the MRI mean is 216. Important thing is that there are several countries in Latin America and also in Europe around the mean, the average, 76%. And let's see now the highest values of R square. Here we have the Canada with 90%, United States with 86%. Here in Europe, we have Switzerland at 84%, and Greece with 93%, and we have 87% for Sweden, and in Latin America, Argentina with 90%. So all the countries that we have studied have an R square high, okay, very high. So with this information, it is demonstrated that the real GDP per capita growth rate is a function of the MRI because the R square is high, okay, and that is the second important thing that we have to demonstrate, to prove.
Now we are going to define the model object, fit the model to the data, make prediction with the model, and validation. Here we have the regression results like the R-square, F-statistic, t-value, and Durbin-Watson. All of them should be carefully reviewed and analyzed in order to be sure that the model doesn't have any statistical issue. Here is the estimated line equation and the errors of the predicted value. And here we can calculate predicted value for a specific year in the data set and score the prediction with the MSE, mean square error, and the R squared. Especially important now is the validation. It is needed to reshape values and create and fit the model. Then we get the overall score for the testing data, and this result should be a low value. And finally, we can see the model fit by plotting the predicted values against the original data. And also we can see the model fit for the US function and just watch how the predicted values are so close to the actual values. You know, I want to make a special mention to the case of the US, just to show how useful is data science to get the best model to explain its macroeconomic performance. The first step is to try with the linear regression, but we all know that it's not the only kind of model. So let us try with some polynomial functions like the second degree poly, and we just compare both results. Hey, looks like we found something. Second degree poly has a better R square than the linear regression and a lower MSE. So why don't we add another line? Let's do this, but we're gonna get Tableau again, okay? Okay, here we have the linear regression with an R square of 85. Then we have the second degree poly with an R square of 89. And we have the third degree poly with an R square of almost 90. All right. After seeing the three lines, I guess that we've got a situation here. Okay, so if we are going to do this just following the statistical result, we have to select the third degree poly because that is what has the higher R square. But you know what? We shouldn't do that. That is a mistake. We need to combine statistical analysis with economic theory and the empirical evidence. And here is the situation. When the country shows MRI higher than 800, you are nearby the full employment, meaning that the economy cannot keep growing at the same rate. And as a consequence, the MRI tend to stagnate. Okay? So we must choose the second degree poly because that is the line that shows the most likely path for the economy. As you can see, it's different. Okay, here the MRI is growing and here is going down, suddenly going down, and this one is just stagnated. Okay, so this is the most probable path of the MRI and the economy. Okay, so this is good to know. Just we can use the data science and we have to combine with the economic theory and the empirical evidence. All right, that's all, folks. Thank you very much.